Okay, so today mostly we'll discuss spherical coordinates. Uh, but first, let me remind you by what we did last time. So we have two types of coordinates that we deal with. The first type of coordinates that we deal with is cylindrical coordinates. Some of you will say this is a polar coordinates. Yes, I mean, you're right. It's a polar coordinates on what? On in the xy plane, and z stays the same. So if x, y, z in rectangular, then we have what? R, theta, and z. This is in cylindrical. Of course, where R radical x squared plus y squared. We will need r squared equals to x, r squared equals to x squared plus y squared. Theta tan inverse of y over x. For the opposite, this for this direction, from rectangular into what? Into cylindrical. If you do the opposite, if you want the opposite, you have r, theta, and z, and you want to find rectangular, you have to use what? X equals to r cosine theta, y equals to r sine theta, and z stays the same. Just use x equals to r cosine theta, y equals to r sine theta. Now for integration in cylindrical coordinates, if you want to integrate over q f of x, y, z dv, this is the same like triple integration over q f of r theta z, but r dv, r dv. dv in this case is what? R dr d theta dz. In rectangular coordinates, this is dx, dy, dz. So this is the first representation of dv, of the volume element, and this is the second representation of the volume element, r dr d theta dz, or r dz. It does not matter which one you started with. Okay, we want to integrate this. Maybe, you know, they will not tell you to use what? To use cylindrical coordinates, but you have to what? To know that you're dealing with what? Polar coordinates. How? There are many indications in this integral that we have to use what? Cylindrical coordinates. Like what? Like x squared plus y squared inside the integral, inside the cosine. X squared plus y squared, this is r squared, the presentation of r squared. Also, if you look to the region dy dx, if you look to the dy dx, this is the upper circle and the lower half of a circle. So we're dealing with circles. Circles, the most suitable coordinates to deal with circles is what? Is cylindrical coordinates. So we have to what? To use cylindrical coordinates in this case. Okay, so now what we need to do, we need to sketch the region in dy dx. Of course, for z, this is from 0 to radical x squared plus y squared. This is z. I'm sorry, r. Yes. Now, what about the region? We have to what? To find the limits for r, dz, dr, d theta. Cosine of y squared is r squared to the power 3/2. Now, what are the limits for r and the limits for theta? Let us sketch these. From 0 to 2, yes, r from 0 to 2. Y equals 4 minus x squared. I mean, if you don't recognize this, just square both sides. Of course, don't forget that y is greater or equal to 0. So y squared is 4 minus x squared. Move x squared to the other side. X squared plus y squared equals to 4. So this is a circle centered at origin with radius 2. This is the upper half. With minus, this is the lower half. So this is y equals to radical 4 minus x squared. This is the other part. Is it a full screen, a full circle, I'm sorry? No. Why? Because the limit for x from 0 to 2, not from minus 2 to 2. From 0 to 2, so from 0 to 2. So we're talking about the right side of the circle, not the full circle. So what's r in this case? R from 0 to 2. Why? This is the region that we are talking about. So R represent the circles, the possible circles that you can draw inside the region. You can do this until the largest circle with radius 2. So from 0 to 2. Now, what are the limits for theta? 2 pi? No. So So we have this angle to this angle. This angle is minus pi over 2. Yes, good. Thank you, Fatima. Yes, from minus pi over 2 to pi over 2. And now you can start what? Evaluating the integral. First integral is dz. dz, there's no need for this expression. You can take it out of the integral. The remaining is 1. The antiderivative of 1 dz is z from 0 to r. Replace z with r, then replace z with 0. So r squared. Yes, Fatima. Excellent. Yes, we need integration by substitution. From minus pi over 2 to pi over 2, from 0 to 2, r squared cosine r cubed, dr d theta. So integration by substitution. There's a multiplication between these functions. So either by substitution or by parts. When you look inside this one, the derivative is what? 3r squared. R squared is here. So integration by substitution. Now the new integral from 0 to 8, r squared cosine of u. U is r cubed, of course. This is u. du divided by the derivative of r cubed, which is 3r squared. Now eliminate r squared with r squared. 1 over 3 outside the integral. The antiderivative of cosine is sine. The antiderivative of cosine is sine. So sine 8 minus sine 0. Sine 0 is 0. So 1/3 sine 8. And the remaining integral is d theta. D theta is theta from minus pi over 2 to pi over 2, which is pi. This is what the final answer. Okay, now let us find the volume of the solid above Z, above this cone, below Z equal to 0, and inside this cylinder. So this is X, Y, and Z. This is very important. This is very important surface, especially in the spherical coordinates. So you need to be familiar with this. So the surface is what below, it goes down. So we have this cone. So we need the surface of this cone. So the solid will form by what? The cone below and by the XY plane up, but within this cylinder. We said that a circle in two-dimensional forms a cylinder in what? In three-dimensional. Why? Because we're adding what? Circles. So we're talking about this portion. Let me zoom it out. We have this. We have a cone downstairs. We're not talking about the cone. We're talking about the remaining, talking about this. So the volume of the can minus the volume of the cone. Maybe this is how you can imagine it, or you can illustrate it. Now, how to find the volume of the solid? Volume is triple integration of 1 dV over Q. Q is what? Q. Z, if you see Z bounded below by the cone and XY plane. So from below, Z equals to minus radical X squared plus Y squared. So minus R. From above, it's bounded by what? Bounded by 0. Okay, now what about the what's about dV? dV, we are choosing what? Choosing polar coordinates. So R, dz, dr, d theta. Now, what about the limits for R and for what? For theta? Yes, good. Yes, Fatima, you're right. All right, so what's dr and d theta? Dr d theta, we're looking for what? For the region. As I told you, if you don't know what to do for the region, just to project the whole solid into what? Into xy plane. This is the xy plane. If you project this solid to xy plane, you will see a circle. If you're sitting above the solid or below the solid, you will see what? You will see a circle. And matter of fact, it's stated clearly inside this circle. R squared is 4, therefore R is 2. So R between 0 and 2. No limits for the circle, so from 0 to 2 pi. And now you can evaluate this integral from 0 to 2 pi, from 0 to 2, R outside this integral, so 1 dz. The antiderivative of 1 is z from minus R to 0. So R, yes. Yes, the antiderivative of R is R cubed over 3, so 8 over 3. And the remaining is what? Just d theta. D theta, the antiderivative is theta, so times 2. So the final answer is 16 pi over 3. Thank you, Fatma. I think 9 we solved it. It's ice cream cone. It's a cone and portion of what? Of so you can what? You can find the volume using cylindrical, and matter of fact, you can use spherical as well. You can use what? Spherical in this case. So before solving 9, I will solve it using cylindrical and spherical. And you can pick, you can choose the suitable coordinates for you. So let me just leave 9 a little bit and into reviewing what we did for what? For spherical. So spherical mainly has what? 3 components: rho, phi, and theta. If you want to convert it to X, Y, and Z, rectangular. X is rho sine phi cosine theta. Y is rho sine phi sine theta. And finally, Z is rho cosine phi. You can do this. Now, what about the opposite? If you have x, y, z, and you want to find what rho in this case is radical x squared plus y squared plus z squared. So it represents the what? The radius of the sphere. If this is the point, this is rho. Now, what about phi? Phi is the angle with the positive z-axis. So if this is the positive z-axis, this is phi. What about as the angle in the xy plane? So if you project this point into xy plane, of course, you will form an angle. This angle is theta. Of course, as we said, phi between 0 and pi. From 0 to pi over 2, we're talking about the upper hemisphere. From pi over 2 to pi, we're talking about the lower hemisphere. Rho can be any positive number. Theta can be a full rotation from 0 to 2 pi. It can be a part of this, but mostly in spherical coordinates, we're dealing with what? Full rotation. All right, so how to find phi? Phi using this formula is what? Z. I'm sorry, it's cosine inverse of Z over radical rho is radical x squared plus y squared plus z squared. And finally, if you want to find theta, theta is what? Is tan inverse of y over x. If you want to integrate using spherical coordinates, integral over q f of x, y, z, dz, dy, dx is what? Integral over q f of rho phi theta. You have to what? To multiply by rho squared sine phi And then what? The limits for rho, the limits for phi, the limits for theta. And you have to remember that a sphere represents a full sphere or any portion of sphere represent rho equals to constant. So if x squared plus y squared plus z squared equals to r squared, this represents rho equals to r. Why? Because this is rho squared. So rho squared equals to r squared, rho equals to r. So remember this. So a sphere is transformed by spherical coordinates, by spherical coordinates to a single value. Also, we proved last time that the cone z equals to radical x squared plus y squared also is mapped into phi equals to pi over 4. And the one below is mapped into 3 pi over 4. So those surfaces is very important to deal with what with spherical coordinates. Maybe some of you will ask, what about if z equals to radical 2x squared plus 2y squared? What I need to do, in this case, you have to place, you have to replace z with rho cosine phi, replace x with rho sine phi cosine theta, replace y with rho square rho sine phi sine theta, and what? Simplify. You will end up with what? With unknown, with known phi. The full equation will end up with what? You can write the full equation as cosine phi equals to a certain number and use your calculator to find phi. But this is the shapes and what? In spherical coordinates. If we have a sphere, rho equals to radius. If we have the cone x squared plus y squared, radical of x squared plus y squared, this is phi equals to pi over 4. If we have the cone z equals to minus radical x squared plus y squared, then phi equals to 3 pi over 4. And remember, phi from 0 to pi, theta, rho can be any positive what? Any positive number. So let's go back to the question that we question in cylindrical coordinates. I want to solve this question using cylindrical and spherical coordinates. So let us solve 9 by what? By both coordinates. So let us start with cylindrical. So 9. Start with cylindrical. So 1 r dz dr d theta. So z, it's above this and below this. So this is the lower limit and this is the upper limit. You need to write it in polar coordinates. In polar coordinates, this is r. What about this in polar coordinates? How to write z equals to 8, z equals 8 minus x squared minus y squared in polar coordinates. Z equals to, just pull minus as a common factor. No, Fatima. 8 minus be what? X squared plus Y squared. So, what's Z? Radical of 8 minus X squared plus Y squared is R squared. That's it. This is the final answer. Now maybe one of you will ask how to find the area, the region. So you have a cone from downstairs, and you have a sphere upstairs, or hemisphere. White sphere or hemisphere, just square this equation. Z squared equals to 8 minus X squared minus Y squared. Move X squared, Y squared to the other side. X squared plus Y squared plus Z squared equals to 8. So this is a hemisphere. So this is the shape that we're talking about. We're not talking about spherical, Fatima, yet. So this is a sphere. This is a sphere. Where's the region? The region that we are talking about. The region will be what? Will be the common area, the common region, the common region. So the intersection. How to find the intersection? I mean, you just write R and radical 8 minus R squared, just intersect them. R equals to 8 minus R squared. R squared equals to 8 minus R squared. 2R squared equals to 8. R squared equals to 4. So R is 2. Yes, so this is a circle of radius 2. Of course, with full rotation. So R from 0 to 2, theta from 0 to 2 pi. And now let us evaluate this integral. R, we don't need it, R, so R is outside. 1, the antiderivative of 1 is Z. 1, you replace it with 8 minus R squared, and once you replace it with R. So it will be something like this. And now you need to integrate this. Then this. Thank you, Fatma. Yes. We need integration by substitution again. So from 0 to 2 pi, you need this to be u. 8 minus 0, 8. 8 minus 4, 4. R, radical u, du times the divided by the derivative of this, which is minus 2r. And this one is easy, r cubed over 3, so 8 over 3. Now r with r. minus half outside. The antiderivative of u is u to the power 3 halves over 2 over 3, from 8 to 4, minus 3 over 8. D theta. So minus 1 over 3. Eight minus 8 radical 8 minus 8 over 3. The whole thing multiplied by 2 pi. And this is the final answer. All right, so now we need to solve the same question, but using spherical coordinates. Using spherical coordinates. We have this cone. We have this hemisphere. And we will form this ice cream cone. And again, the intersection is this circle. So how to do that? How to find the limits for what? For rho, for phi, for theta. One is what is theta. As you see, we have a full rotation. We have a full rotation. So theta between 0 and 2 pi. Now, what about rho? Rho is the distance between what? Between the points and the center. If you see, if you draw now, rho is constant throughout the solid. The same until this point. So why? Because of this sphere. What's rho in this case? Rho represents the radius of this sphere. How to find the radius of this sphere? Just square both sides. Move x squared, y squared to the other side. This is your rho squared. Excellent, Fatima, yes. Rho squared equals to 8. Therefore, 8 rho is radical of 8. So rho between 0 and radical 8. What about phi right now? What about phi? Phi is the angle with the positive z-axis. So this is the positive z-axis. From 0 to pi over 4. Yes, correct, Fatima. You're right. You see, phi will do this. You move slightly and rotate. You move slightly, then rotate. You move slightly, etc. The maximum value for phi is this. Which represents what? The surface of the cone. The surface of the cone, I just mentioned it. This is very important surface in spherical coordinates. So phi will be between 0 and pi over 4. Okay, so we are ready right now to what? To evaluate what? The volume. The volume 1 times rho squared sine phi d rho d phi d theta. Rho from 0 to radical 8. Phi from what? Phi from 0 to pi over 4. Theta from 0 to 2 pi. Now integrate what? Integrate d rho. So there's no need for sine. Integrate rho squared, rho cube over 3. Yes. So 8 radical 8 over 3. Now sine phi d phi d theta. So 8 radical 8 over 3 minus cosine, yes. Thank you, Fatima. Minus cosine phi from 0 to pi over 4 d theta. If you substitute pi over 4, 1 over radical 2 minus 1 over radical 2 plus 1. Integration from 0 to 1 d theta. D theta is theta from 0 to 2 pi. So 2 pi, yes. So 8 radical 8 over 3 minus 1 over radical 2 plus 1. The whole thing multiplied by 2 pi. This is the final answer. This is the volume. All right, after the break, we'll continue, inshallah, talking about spherical coordinates. Okay, assalamu alaikum. So let us solve this equation. This is a similar question, similar example to what we did before the break, but the cone is not going up, going down. It's going what? Down. So what we need to do, how this rotation will affect what the limits for rho, theta, and phi. I think you remember from the previous class, I said that the upper hemisphere represent theta between 0 and pi over 2. The lower hemisphere represent the values for phi between what? Between pi over 2 and pi. So if we're talking about if we're talking about a portion of or a solid which is which downstairs, below the xy plane, then phi must be between pi over 2 and pi. From what? From pi over 2 to pi. So let us sketch this solid and determine suitable values for rho, phi, and theta. So we have a sphere with radius 3. So rho squared equals to 9. Therefore, rho is 3. So you have a full sphere with radius 3. Now we have a cone. As I said, because of this minus, it goes downstairs. Why? Z is minus, so it's less than or equal to 0. So the cone going down. We have this cone. And of course, we're talking about, again, the ice cream cone. Talking about this portion. This is the solid S. Okay, so what's limits for rho? Let's start with rho. I mean, take any start rotating inside this cone. Rho will stay the same. You see, rho will stay the same. From 0 to 3, yes. Rho here, the maximum value for rho at this surface. This surface on the sphere. Rho equals to 3. So rho between 0 and 3. Now what about the angle with the positive z-axis? So this is positive z-axis. Inside the cone, of course. This is the minimum rotation for what? For rho. So this is the minimum value for rho. Then this rotation will increases and increases until we reach the maximum rotation for phi. Maximum rotation for phi is what? Is pi. No. I'm saying the maximum rotation for phi is pi. So this is when phi equals to pi. Now, what about the minimum? Yes. What's the minimum value for phi? This is the minimum value of phi. I mean, it's only the difference between the minimum value of phi and pi is acute angle. So it will be something what close to pi. Close to pi, I mentioned at the beginning of this this session that z equals to plus radical x squared, phi equals to pi. But when z equals to minus radical x squared plus y squared, 3 pi over 4. Thank you, Fatima. Yes. 3 pi over 4. Some of my colleagues told me that most of their classes they some they feel that they're talking to to themselves only during the class. But I'm happy at least I'm talking to Fatima. Fatima is responding. So at least there's a student I'm talking to. So phi between 3 pi over 4 and pi. Hopefully, okay, good, good. I'm happy. Hafsa is here also. Sheikh is also here. Good. Fatima here. Fatima Ali is here. Good. So phi between 3 pi over 4 and pi. But please stop me if you don't understand a certain point, especially the limits for phi. This is crucial point for what? For spherical coordinates. So a cone going up, the limits for phi between 0 and pi over 4. A cone going down, the limits for phi between 3 pi over 4 and between 3 pi over 4 and pi. So this is mostly the game in spherical coordinates. Or of course, we don't have cones at all. So phi will be the upper hemisphere or the lower hemisphere or a full sphere. So you see, you have what? 5 cases in spherical coordinates only. You have full sphere. If you have full sphere, phi between 0 and pi. If you have upper hemisphere between 0, of course, I'm talking about without cones. If we're talking about upper hemisphere between 0 and pi over 2. If you have lower hemisphere from pi over 2 to pi. If you have a sphere and a cone, or only a cone going up, going toward the positive z-axis, phi between 0 and pi over 2, pi over 4, I'm sorry. If you have a cone going down toward the negative x-axis, then phi between 3 pi over 4 and pi. Now, what's theta? Theta represents what? The intersection circle. So this is the intersection. So it has what? Full rotation from 0 to 2 pi. I mean, if you cut the solid here and you look to the cross section in this cone, you see a circle. So theta between 0 and 2 pi. Now you can what? You can evaluate this integral. So from 0 to 2 pi, from 3 pi over 4 and pi, from 0 to 3, from 0 to 3, x squared plus y squared plus z squared, this is rho squared to the power 3 over 2. And dv is rho squared sine phi d rho d phi d theta. Very good. So rho to the power 5. No need for sign, so sign outside. Thank you, Fatma. So rho to the power 6 over 6, you mean? The final answer, you mean? Okay, good. So rho to the power 5, rho to the power 6 over 6, 3 over 3, 3 to the power 6 over 6. From 0 to 2 pi, from 3 pi over 4 to pi, sine phi, d phi, d theta. So 3 to the power 6, she found it. 243 over 2. Now the underderivative of what? Of sine minus cosine. Yes, minus cosine pi, which is 1. So this is minus cosine phi from 3 pi over 2, 4 to pi. And the final answer is just multiplied by 2 pi. 243 times pi, the whole thing multiplied by 1 plus 1 over radical 2. All right, so now they're asking us to change this integral from rectangular to spherical coordinates. So this is the xy plane. This is a hemisphere. This is a hemisphere. So xy plane and a hemisphere. Now I expect that this region is, we're talking about this, the base or part of it. Part of this what? Of this region. Is it full region or part of this region? Is it the full base or half of the base or part of the base or what? Half. Yes. Half of the base. Yes. Good. Good. Very good. So in which theta is what? Of course, in the base we care about only about theta. Why? Rho represent what? The radius of the sphere. The radius of sphere. Clearly, if you square both sides, z squared is 4 minus x squared minus y squared. Therefore, rho squared is 4, and rho equals to 2. Yes. So this is the limits for rho. The limits for rho from 0 to 2. Also, the limits for phi, it does not affect it by what? By does not affect by what? By what happened in the base. It represents the rotation from what? The positive x-axis. The rotation from positive x-axis, it goes this way, this way, this way, this way, to pi over 2. No, to pi over 2. As I said, Fatima, we don't have cones in this case. The cone will what? Make the range for phi smaller. If we only have spheres, if you're dealing with upper sphere, phi between 0 and pi over 2. If you have a lower hemisphere, from pi over 2 to pi. All right, so phi between 0 and pi over 2. Where's phi equal to 0? This is phi equal to 0. Then go this way, this way, this way, until it covers what? It covers the whole solid. Okay, the last thing is what? The last thing, we need the limits for theta. What are the limits for theta in this case? So sketch this region. Sketch this region. From 0 to, so we have semicircle, y equals 0. And from -2 to 2. From -2 to 2. So yes, this portion. Excellent, Fatima. Yes, from 0 to where? To pi. Yes. Thank you, Fatima Ali. Yes, from 0 to pi. And you have to change what's inside this integral. X squared plus y squared plus z squared. This is rho squared. And now you can integrate this. Sin phi again, we don't need it outside. Rho to the power 4, so rho to the power 5 over 5. From 0 to 2. We have sin phi from 0 to pi over 2. From 0 to pi d phi d theta. 32 over 5 outside. And now the antiderivative for sine. Antiderivative of sine minus cosine phi from 0 to pi over 2. If you replace phi with pi over 2, 0, minus 1, yes, it is 1. So the final answer is 32 pi over 5. Mhm. This example exactly the same like what we did just right now. Exactly the same. But you need integration by substitution because of this. This one, like what you did for the question when we solved it, so when you use the cylindrical and spherical. Phi, in this case, between 0 and pi over 4. Rho, between 0 and radical 2. Theta, between 0 and 2 pi. And this is rho. Straightforward example. All right, so let's see. This is a cone with sphere. The intersection is a circle. The sphere, the cone is the one which goes up. So phi between 0 and pi over 4. This means we did that before with the same quantity, rho between 0 and radical 8, which is 2 radical 2. The region will determine what the limits for theta. The limits for theta is what from 0. We just solved it just a minute ago, from 0 to pi. That's it. This is the, and of course, this is rho cube. All right. So what are the limits for for rho, for phi, for theta for this example? And you can continue. So the last one theta, we just solved this example from -2 to 2, and the arc with y-axis, so theta from 0 to pi. Now what about theta? What about phi and rho? Do you see any cone, Fatima, in this question? So why is it pi over, yes, and why from 0 to? Is it the one below this, the one below? What does it represent? This surface is a sphere. It's not a sphere, it's a hemisphere, the lower hemisphere. To 0, of course, z equals 0, which is what? The xy plane. So we're talking about this, xy plane from above, from below a hemisphere, lower hemisphere. So what's phi in this case? This is the positive z-axis. The minimum rotation is 90 degrees. Then it starts to get larger. To the last one, which is what? Pi. So from pi over 2 to pi. There's no minus pi over 2, Fatima. We said phi between 0 and pi. Are we covering the upper hemisphere? The upper hemisphere from 0 to pi over 2. The lower hemisphere from pi over 2 to pi. Okay? Okay, what about the limits for rho? Yes, from 0 to 2. Excellent, Fatima. Yes. Thank you, Fatima Ali. Fatima Abed. Yes, from 0 to 2. And of course, you can now start what? Evaluating this integral. This is only e to the power rho squared sine phi d rho d phi d theta. And these are the limits for rho, phi, and theta. Don't forget that you want this time you don't want integration by substitution. You need integration by parts. Integration by parts. Rho squared, 2 rho, 2 and 0. E to the power rho stays the same. Plus and minus, then plus. So rho squared e to the power rho minus 2 rho e to the power rho 2 e to the power rho from 0 to 2. Then the remaining is straightforward. Just evaluate the integration for sine, and that's it. D phi, d theta. From pi over 2 to pi. from 0 to pi. This is the final answer. Let me check also. There's another page. Okay, so I think I'm done for